Hello, college algebra. Today we take a look at how quadratic equations can come up in various types of word problems. One thing that I would recommend is as you're starting your homework tonight, try it on your own. But if you're really stuck, there are recorded videos of each question worked out. And these videos are actually by the teacher that I was trained under. She's very good. She has excellent explanations. So I would really take advantage of those. But again, just as you need them. Okay, let's go ahead and start these notes together. Share the screen. Oh, there's my face. And let's go ahead taking a look at number one. Number one, it says a half-acre building lot is 5 times as long as it is wide. What are the dimensions of the lot? And the first thing that we would want to do is draw a picture because I'm looking at a lot, which is typically a rectangle. It says, what are the dimensions of the lot? And we're looking at the dimensions described in terms of width and length. So I'm going to let X represent the width of the lot. And we know from geometry that if one side has a length of X, the opposite side has the same length. And then if we're looking, or sorry, if one width is X, the other width is X, and then it says the length is 5 times as it is wide. So the length would be 5 times X and 5 times X. So X equals the width of the lot and 5 times X would equal the length. Now, what are we told about the lot? We're told that it's a half acre and we're told what the area is of 1 acre. So since we have the entire lot is 1/2 acre, we know that the area of the lot would be 1/2 of that square footage, 43,560 square feet. Now, remember from geometry that an area of a rectangle is equal to its length times its width. So since this is a half acre, I'm going to take 1/2 of 43,560 and set it equal to the length, which is 5x, multiplied by the width, which is x. I'll go ahead and multiply that out on my calculator. Half of 43,560 would give me 21,780. X times x is x squared. If you just have an x squared, it's easiest to solve by getting that by itself and taking the square root. So I'll divide both sides by 5, which gives me 4,356 is equal to x squared. Then what undoes a square root. What do I need to keep in mind when taking the square root in an equation? Plus or minus answer. Now here is the tricky piece about quadratics when they show up in word problems. Almost always, not always, but almost always, we have to throw a solution away. So we have to go back to the problem and say what makes sense. If I look at the width, which is represented by X, it could be 66, but it could not be a negative 66. So we just have to throw away that answer. And then the length would be 5 times 66, which would be 330. So if they ask me what are the dimensions of the lot, I could say 330 by 66. And then I do want to use units. Length and width come in singular units. So that would be feet. All right, that's the first type of problem. Type number 2 involves area with borders. So let's take a look. It says Cynthia is buying a rug for a room that is 12 feet wide and 15 feet long. She wants to leave a uniform strip of floor around the rug. She can afford to buy 108 square feet of carpeting. What dimension should the rug have? So the first thing I like to do is draw a picture to visualize what's happening. And it says we have a room that's 12 by 15 feet. So I'm going to go ahead and set that up. 12, into shape, man. 12 by 15. And then it says she's buying a rug with uniform strip around it. Uniform strip means equal length of strip all the way around. So I'm going to go ahead, use my ink to shapes tool and draw a rug that's just about hopefully trying to be uniformly placed inside of the room. That's better. Now, a uniform strip means that whatever length this is the same as this, the same as this, and the same as this. They don't tell us what it is, but we can represent that uniform strip as the same value. So I'll go ahead and let X be this. And that looks kind of funny. Let's wipe that out. So I'm going to let X be this value, this value, this value, and that value, which kind of looks funny, but that's X. Now, what else am I told? I'm told that she can afford to buy 108 square feet of carpeting. So that's area. So that tells me the area of this carpet is 108 square feet. Now, what am I trying to solve for? It says, what dimension should the rug have? So I need to let something represent the width and another value represent the length. If I'm looking at the width of the rug, that's this piece right here. I'm not given any information about that particular part of the rug, but I am given information about the width of the entire room, which is 12. And I know the uniform strip around that rug has the same value, so X and X. So if I'm looking at what can I represent this piece of to have, it would be 12 and then subtract the value of X and another value of X. How do we represent that? Using an algebraic expression, just 12 minus 2 times X. Now, see if you can use that to help you determine what would be the length of the rug. Okay, hopefully you were able to see that it's 15 minus 2 uniform strip lengths, so 15 minus 2x. Okay, now we know that the square footage of the rug is 108. How do you find the area of a rectangular piece? Well, we know area again is equal to length times width. So the area of the rug, which is 108, is going to equal the length of the rug, which is 15 minus 2x, times the width of the rug, which is 12 minus 2x. So when they ask what dimension should the rug have, we're going to let 12 minus 2x represent the width and 15 minus 2x represent the length. I always like to define what I'm solving for, which usually comes from the end of the problem. Okay, how do we solve this? This is a quadratic because I'll have x times x. So I have to think about what methods I know to solve a quadratic. The first thing I'm going to do is multiply this out. So 15 times 12 gives me 180. So that would be first times first, outside times outside would give me negative 30x. Inside gives me negative 24x. Last gives me positive 4x squared. I can combine those two like terms to be negative 54x plus 4x squared. Now, this is a quadratic, so you should be thinking, I know quadratic formula, I know how to complete the square, and I know how to solve by factoring. Factoring should give you rational number solutions. So if I'm looking at the value of x, which represents a uniform strip, does it make sense that that should have a rational number answer, like 1 or 1.5? In my mind, yes, I think it should be rational. So that gives me the clue that this is probably factorable, which is my favorite method of solving. But you could have used the quadratic formula or whichever is your favorite method. I'm going to go ahead and set this equal to 0 and see, can I factor it to solve? So I'll subtract 108, which will give me 0 is equal to, I'm going to rearrange this in the order that I know needs to be shown for factoring. So 4x squared minus 54x. And then this value right here, 180 minus 108 gives me 72. First step in factoring is to take out a GCF. Since I see that all of these can be divided by 2, I'm going to divide this by 2 and this by 2 to give me 0 is equal to 2x squared minus 27x plus 36. Then my favorite part is factoring. The last term is positive. So I know that tells me that I'm going to have the same signs as the middle term, minus and minus. 2x times x would give me 2x squared. If I think about factors of 36, 36, I could try 6 and 6 because they're the closest, but I can't put a 6 in with a 2 because that would create a GCF. So no good. I could try 9 and 4. I would have to put the 9 in with the 2 and the 4 here. But if I check, negative 8x plus negative 9x is negative 17x. No good. So that's not going to work. The next factors of 36 I would look at would be 12 and 3. I'd have to put the 3 in here and the 12 in here. Let's see if that works. Negative 24 plus negative 3. Yes, that's negative 27x. So I set both of these equal to 0 and solve. X minus 12 equals 0. And I get that x might equal 12 or x might equal 3/2. Or you could say 1.5. Now, which of these makes sense in the context of the situation? X represents the uniform strip. So if I look at the uniform strip, if the entire room has a width of 12, does it make sense that I could put a uniform length of 12 around the rug? No, that does not make sense. So this needs to be thrown away, which means the uniform strip is 1.5 feet all the way around the rug. And that's going to help me solve. It says, what should the length and the width have? The width would be 12 minus 2 times 1.5, 12 minus 3, which is 9 feet. And the length is 15 minus 2 times 1.5, 15 minus 3, which is 12. So the dimensions are 9 feet by 12 feet. That's it. Okay, let's take a look at the next type. Often quadratic equations come up when you are using the Pythagorean theorem. So good. So let's go ahead and take a look at how this would come about. Two cars left an intersection at the same time, one heading due north and the other heading due west. Sometime later, they were exactly 100 miles apart. The car headed north had gone 20 miles farther than the car headed west. How far had each car traveled? Okay, so again, I like to start with a picture. If I'm looking at an intersection, one thing you might want to remember from an intersection is never eat soggy waffles, north, east, south, and west. So if two cars are heading from an intersection and one is heading due north, it would be going this direction. One heading due west would be heading this direction. And it says after some time, they were exactly 100 miles apart. So if I have one little car over here and another little car over here, if they're 100 miles apart, that distance would look like that. Now I'm looking for how far has each car traveled. So I could call this like car 1, this one car 2. And it says the car who's headed north, so that's this direction, has gone 20 miles farther than the car headed west. So I'm going to let X represent the distance traveled by the car heading west. Then how would I represent the one going north? Well, it says he's gone 20 miles farther. So that would be whatever the distance is plus 20. Now this is a right triangle, which is important because one's going exactly that direction, the other one's going exactly the other direction, so it's making a right angle. And we know from geometry that in a right triangle, the leg squared plus the leg squared has to equal the length of the hypotenuse squared. So I'm going to go ahead and write that in. You might know it as a squared plus b squared equals c squared. Miss Gregerson is very particular, and I like it because it helps you remember which piece represents a, b, and c, and it's always the hypotenuse squared. So I'm going to put that in as x squared plus x plus 20 squared is equal to 100 squared. Now this is a quadratic. I need to go ahead and start solving. So 100 squared, that's going to give me an answer of 10,000. I'm sorry, 10,000. So that's equal to 10,000. X squared is just x squared. This guy, I know I need to FOIL. So that's going to be x squared plus 20x, which will give me 40x plus 400. It's a quadratic, so I'm going to combine those like terms, which will give me 2x squared plus 40x. And then my, again, favorite form of solving is factoring, but I have to make sure my answers would probably be rational number answers. Typically, we talk about distance as whole values or maybe 0.5. So I would think it's going to be a rational number answer. So that's going to tell me that this is probably factorable. So I'll subtract 10,000 from both sides. And that would give me 2x squared plus 40x minus 9,600 is equal to 0. I see that everything's divisible by 2, so I'm going to divide by 2, and that gives me x squared plus 20x minus 4,800 is equal to 0. And then if I'm looking at, well, what pieces could work here? The last term is negative, so that tells me I'm going to have different signs. X times x would give me x squared. And if I'm looking at what factors would work of 4,800, I know 48, 6, and 8 are very close. So if I think about 60 and 80, if I make the 60 negative and the 80 positive, that should work. And I'll find that x is going to equal 60, or x could equal negative 80. What? Let's think about what x represents. X represents the distance gone by the car heading due west. So could it be negative? No, which means the distance that the car has traveled west would be 60 miles. And the one headed, it says how far had each car traveled. So the one heading north is going to be 60 plus 20, which is 80. And those are my answers. All right, last one. We get to use the chart again. It's a distance, rate, and time problem. So here we go. A boat traveled upstream a distance of 12 miles. On the return trip downstream, the boat traveled 3 miles per hour faster. If the return trip took 8 minutes less time, how fast did the boat travel upstream? There's distance, there's rate, there's time. I'm ready for a chart. So I know distance is equal to rate times time. There's two pieces I'm comparing. The boat is going upstream and the boat is going downstream. I like to start at the end of the problem because that tells me where I'm going to begin in my chart. It says, how fast did the boat travel upstream? So I'm going to let x represent the rate the boat travels upstream. So that means this would be x. And now what does it say? Because I want to fill in the entire column. What does it say about the boat traveling downstream? It says downstream, the boat traveled 3 miles per hour faster. So how do I represent that? X plus 3. And we could look at this as miles per hour. The next thing, they have to either give me the distance described in the problem between upstream and downstream or the time described upstream and downstream. So what did they give me? They said the boat traveled upstream a distance of 12 miles. Well, I can use that because if they're going upstream and then they're coming back, they're traveling the same distance. So I know that this would have to be 12 miles and this has to be 12 miles. Once I have two columns filled in, I fill in the third using those two. So how is time found using distance and rate? Time is equal to distance divided by rate. And I can go ahead and solve then. Distance divided by rate, this would be 12 divided by x. This would be 12 divided by x plus 3. Lastly, I use the last column filled in and set up an equation with what's being described. So what does it say about the time going upstream and downstream? It says the return trip took 8 minutes less time. So as I'm thinking about how to set up the equation, I want to make sure to process which one is taking longer, upstream or downstream. And you would think upstream is taking longer, downstream is taking less time. So if I want to equate the two values, there's really two ways that we could do it. The time ups, actually, you might want to pause the video and try to think it through for yourself, but I'll go ahead and keep just explaining. The time upstream is longer. So if I want to equate it, make it equal to the time downstream, I have to accommodate for the fact that downstream took 8 less minutes. So I'm going to go ahead and subtract 8 minutes from the time upstream in order to equate it to the time downstream. Or if you don't like to think about it like that, you could say the time upstream is equal to the time downstream plus 8 minutes. Now you've equated the two because the time upstream takes longer. Okay, or the other way I've seen people do it is take the time upstream, subtract the time downstream, and that will equal 8 minutes because there's an 8-minute time difference. Okay, I'm gonna go ahead and solve the first setup. So again, this was miles per hour and this is miles. So if you're thinking about time represented as distance divided by rate, miles divided by miles per hour is equal to miles times hours over miles. This is given to us in hours. So I do have to stop and think, wait a minute, this time is described in minutes. So I have to convert from minutes to hours. If you're using the science method, if you're asking, how do I convert 8 minutes to hours? I want to end with hours. There's 60 minutes in 1 hour. And so notice the minutes cancel and we would have 8/60ths of an hour. So I'm going to go ahead and say this is 8/60ths of an hour, AKA, let's see, those are both divisible by 4. So 2/15ths. And I'm going to go ahead and put these pieces in. Time upstream is 12 over x minus, that's reducible. So I'm going to call it 4/5 or divided by, 2/15ths is equal to the time downstream, which is 12 over x plus 3. What is the least common denominator here between x, 15, and x plus 3? They share nothing. So it's actually going to be all of them multiplied together. So I'm going to multiply this side, it's supposed to be red, by x times 15 times x plus 3. I'm multiplying it into a fraction, so I'm multiplied over 1. Because this side has 2 terms, I'm going to distribute that in, x times 15 times x plus 3. Same here, x times 15 times x plus 3. And now simplifying starts occurring. What cancels here? The x's cancel. And I have 15 times 12, 15 times 12 times x plus 3. So I'm going to do 15 times 12, which is 180 times x plus 3. Minus what cancels here? The 15s cancel. So I have 2x times x plus 3. What cancels on the right side of the equations? The x plus 3's cancel. And I have 12 times 15, which I already determined to be 180 times x. I'm going to simplify this out. So that's going to give me 180x plus 540. Distribute the negative 2x minus 2x squared minus 6x is equal to 180x. This is a quadratic, so I'm going to put it into the proper format. I'm going to put the squared term first. So I have negative 2x squared, 180x, and negative 6x come out to be 174x plus 540 equals 180x. Subtract 180x and set this equal to 0. That gives me negative 2x squared. Uh-oh, it froze. Like you were writing too fast. You guys probably thought the same thing. I'm sorry. There's somebody outside my door. And so I just was trying to be like, what do you need? But I'll slow down because even my computer's not happy. Here we go. So subtract the 180x to continue to set it equal to 0. And that gives me negative 2x squared minus 6x plus 540 is equal to 0. I'm going to factor out the -2, which would give me x squared plus 3x minus, what's 540 divided by 2? 270 is equal to 0. And then the -2 can't equal 0, so we can go ahead and throw that away. And then as I factor this down, I have x and x. The last term's negative, so I'm going to have a plus and a minus. And the factors that work here are 18 and 15. If I try to see, could x equal -18? X represents the rate. So no, x could not equal -18. But could x equal 15? Oh, why, sure it could. So it says, how fast did the boat travel upstream? 15, and I want to make sure I use my units 15 miles per hour. That's it.